So let's turn to an example scenario to talk about capital budgeting more in depth. Specifically, we're going to focus on Hogarth Incorporated again. They're considering the purchase of a special purpose bottling machine. $23,000 is the amount of the purchase. It is expected to have a useful life of 4 years with no terminal disposal value. What that means is that at the end of its useful life, it's not worth anything to us. The plant manager estimates the following savings in cash operating costs as a result of this purchase. Specifically, in year 1, we'll save $10,000 in costs. In year 2, our savings go down, but it's still $8,000. In year 3, we'll save $6,000, and in year 4, we'll save $5,000. The total savings over the life of the machine is $29,000. Notably, Hogarth uses a required rate of return of 16% in its capital budgeting decisions. And we're going to assume that all cash flows, specifically the cash savings, will occur at year end, except for the initial investment amount, which will occur at the beginning of time 0. Now, a few notes to consider here. First off, the investment amount and future cash flows are estimates. And considering the multi-year span of this project, it is often difficult to make reliable estimates, especially that far into the future. Uncertainty here plays a substantial role. Also, what is this required rate of return? Well, it is the return required by the firm to make an investment worthwhile. This rate is determined by upper management and is influenced by many factors, including risk preferences, market conditions, and other opportunities. So what's the ultimate question here? First of all, should Hogarth make this investment? There are multiple measures and approaches used in capital budgeting to help address this question. Often managers will use a variety of measures and approaches, and this allows for a broader perspective to ultimately facilitate their decision and make it more informed. Let's back off of the Hogarth example for a second and look at something that we'll just keep on the back burner. Let's consider a firm that's comparing multiple investment alternatives. We have a multi-year span project, 2 of them, Project A and Project B. And in year 0, Project A would require an outflow of cash of $100,000. Project B would require an outflow of $250,000. Project A has a series of cash inflows or perhaps savings along the way. In year 1, 2, 3, 4, 5, and 6, there are positive cash flows or cash savings ranging from $10,000 up to $80,000. And as you can see across the year span, the amounts differ by year. Project B differs on this dimension a bit. Early on in its life, years 1 through 4, there's very small cash flows or cash savings, ranging from $1,000 to $2,000 to $3,000. But then at the end of the project's life, year 5, there is a substantial savings of $20,000, followed by in year 6, the real big savings or large cash inflow, $390,000. Now ultimately, it's very difficult to compare these 2 projects, Project A and Project B, given the nature of the outflow at the beginning of the project, as well as the variety of the inflows over the life of the 2 projects. Capital budgeting techniques will help us solve this problem. Try to equate all of the information across projects so that we can make the appropriate decision.